So today we're going to be talking about using DNASTAR Cloud to manage large next-gen sequencing data sets. To get started, I'll give you a brief introduction to DNASTAR software, including our applications for desktop computers and the DNASTAR Cloud. And then we'll get into a live demo of cloud assemblies as well as some downstream analysis options. And then at the end, we'll have time for some questions. So just a brief introduction to our software. DNASTAR LaserGene is our flagship product and consists of three major components. Our molecular biology suite, which handles everything from cloning and primer design to Sanger sequence assembly and analysis to multiple sequence alignment and phylogenetic tree creation. This integrates with our genomics suite, which handles a variety of next-gen sequencing applications and technologies, both assembly and downstream analysis in one integrated package. And finally, our structural biology suite contains tools for protein sequence and structure analysis, as well as protein structure prediction. And since we're talking about the DNASTAR Cloud today, it's worth mentioning that in addition to our cloud assemblies, which we'll be looking at shortly, our structural biology tools also integrate with the DNASTAR Cloud, allowing you to take advantage of cloud computing resources to predict protein structures. If you're interested in that, please check out our NovaFold webinars. Those are available on our website. We also have some shorter videos on that topic as well. All of this software is available in a variety of licensing options to best meet your organization's needs. We also have all of the software is available on a desktop computer, which is our traditional method of delivering the software, what most of our users use. But we also have cloud options for all of our applications. So if you want to use a virtual machine for your analysis, you can do that as well. And that's where we'll be focusing our attention today. So the DNASTAR Cloud is hosted by Amazon Web Services, and it's comprised of three major products. First, our DNASTAR Cloud Desktop allows you to do all of the analysis you would do on a physical desktop computer using a virtual computer and accessing that computer through the Amazon Workspaces app. So if you're not familiar with Amazon Workspaces, this is an app that you would install on your Mac or Windows computer or on a mobile device such as an iPad or Android tablet. And then from there, you can actually use the software just as you would on a normal desktop computer. So this is a really nice option for people who are away from their computers or need an option to collaborate directly with peers. The cloud desktop on Amazon Workspaces is something to look into. And the second product we offer is DNASTAR Cloud Assemblies. So today we'll actually be looking at DNASTAR Cloud Assemblies to assemble multiple genomes. The Cloud Assemblies application works just like the assembly tools in our LaserGene Genomics suite for the desktop computer. So all of the same workflows and technologies are supported on the cloud as on the desktop. And then finally, our DNASTAR Cloud Data Drive, which integrates with both of these other cloud products to store and transfer data. And we'll look at the DNASTAR Cloud Data Drive as well because that integrates so closely with the Cloud Assemblies platform. So DNASTAR Cloud Assemblies, if you're not familiar, this, as I mentioned, supports all of the same workflows as our desktop computer. And that's everything from de novo transcriptome to RNA-seq, gene expression analysis, targeted sequencing projects like gene panels and exomes, cancer panels, full genomes, as well as multiple genomes. And the same goes for multiple exomes, multiple RNA-seq samples. So all of these workflows tie into our analysis tools where you can do things like variant analysis, multiple sample comparisons, CNV analysis, and gene expression analysis. And then in addition to all these workflows, we also, of course, support all the major sequencing platforms. Just to note, our desktop genomic software does run on pretty modest hardware. We design it with researchers in mind, and we try to make powerful software that can also run on a computer that is accessible to most researchers. So if you want to do your assemblies locally, you'll need a computer with 16 to 32 gigabytes of RAM, and then some external hard drives with anywhere from 1 to 8 terabytes of space. And this just depends on how large your data sets are, how many samples you have, or how deep the coverage is, for example. So for most users, this hardware is not an issue. But if you don't want to get this kind of setup going, say for smaller projects or for a single user, if you don't want to make that investment, the cloud assemblies are a great alternative. So how do DNASTAR Cloud Assemblies work? Well, as I mentioned, these cloud tools are hosted by Amazon Web Services, and they integrate into the DNASTAR LaserGene software directly. So from your desktop computer, you'll upload your data to the DNASTAR Cloud data drive, where it's stored in an encrypted format. It's also compressed on upload and download to make for really fast data transfer between the ground and the cloud. And then the data drive sort of talks to the Cloud Assemblies application, which can read that data to do your assemblies. Once the assemblies are complete, the results go to the data drive, again in an encrypted, compressed format, and are downloaded by the user onto your local computer or onto a DNASTAR Cloud desktop virtual machine, if that's your preference. And then once you've downloaded the results, you can do all of your analysis in our standard LaserGene Genomics suite applications, either on your desktop computer or on a virtual desktop. So here's some screenshots showing what those analysis tools look like. We'll briefly touch on some of this analysis today once I show you how to complete the cloud assemblies. So with that, let's get into the software. And we'll start out in the DNASTAR Navigator. And from the DNASTAR Navigator, you'll see the software is divided into some different categories. So you see molecular biology, genomics, transcriptomics, structural biology. So clicking on any of these buttons will open the desktop version of that application. And then you'll also notice we have a section devoted to the DNASTAR Cloud. So from here, you can open up the DNASTAR Cloud desktop, DNASTAR Cloud Assemblies, or your cloud data drive. And as I hover over each button here, I get a short description of what the app does, as well as some links to videos and other training materials, and sometimes some demo data. For example, to go up to NGen, you see we get the tutorials and demo data. So the Navigator is a great resource for just using the software on a daily basis, but also familiarizing yourself with our software. So some really nice training resources right here. So today what we're going to do is assemble 4 salmonella genomes using our DNASTAR Cloud Assemblies. So I'll just click that. And that launched SeqMan NGen. And so this is the same application that you would use to run assemblies on your local computer. In fact, you'll see you have some options here to assemble locally, including rerunning a local assembly. But because we came from the Cloud Assemblies button, Assemble on the DNASTAR Cloud is pre-selected. And so then from here, you'll just enter your DNASTAR login credentials. And when I click Next, you'll see I'm prompted. I just see how many assemblies are remaining on my license. And now you have the choice to start up a new cloud assembly or monitor an existing assembly. So first, we're actually going to do a new assembly. So I'll select that. And then I'm presented with a choice of workflows. So again, this screen is going to be identical whether you're working on your desktop computer or on the cloud. So you just need to choose what workflow you're doing. In this case, we're doing some whole genomes. So I'll select that. I'm going to do a templated assembly. You'll see we also have de novo assembly, reference guided assembly with gap closure if you're trying to close some genomes using a closely related reference sequence. And then we have some special templated workflows for unique cases. So the next step is to input your template sequences. I want to point out here we have our DNASTAR genome template packages. So these are already on the DNASTAR Cloud data drive. And you'll see we have several organisms listed here. If you're working with a model organism, we recommend using these template packages. If you don't see your organism listed here, give us a call. We may be able to add it. What these template packages are a combined set of reference sequences and SNP information. So you see we have information from dbSNP here. There's also cosmic and GURP annotations in these genome template packages. So especially if you're going to do any kind of variant analysis downstream, definitely recommend checking out our genome template packages. In this case, I'm going to add my own GenBank file as a reference sequence. And when I click Add, that opens up this DNASTAR Cloud data drive. And I didn't mention, but just as a tip or a shortcut, I really prefer to upload all of my data ahead of time. So if we go back to our NGen window, let's close out of the data drive. If we go back to the Begin Project screen, you'll notice this button here to upload data. And it really saves time to upload your data to the Cloud data drive first. When you click that, you'll get this Cloud data drive window that we just saw. And here you can organize all of your files into folders and subfolders. So I recommend uploading your reference sequences, your read data, and any auxiliary files you're going to be using. So let's come back to our set reference. So when I click Add, it opens the DNASTAR Cloud data drive. And so here we see our folder structure. I'm going to navigate to my Salmonella strains folder and add a GenBank file. Now, let's say you forgot to upload your data ahead of time. You can just click this Upload Download button, and that'll allow you to add more files right here on the spot. So now I've added my GenBank reference sequence. You can add multiple reference sequences here. You can also add a VCF file. So if you're doing some custom SNP analysis and you want to check variants against your own database, you can load a VCF file for that right here. This is a totally optional step, but in this case I do have a VCF file, so I'll go ahead and load that. Next, I'm going to select my read technology and then load my read data. So I click Add, and again, this is going to open up the DNASTAR Cloud data drive, and now I'm just going to navigate to those reads. And so this data set actually has 18 Salmonella strains. Just in the interest of time, I'm going to load 4 today. So I'll select all my FASTQ files and add those. You'll see I'm prompted to set up the pair insert size. And then you can see all of the FASTQ files loaded right here. In this case, we're running multiple genome assemblies, so I'll select multiple samples. And you'll notice that automatically checks Run as separate assemblies. And so what this is going to do is, up on the cloud, run 4 assemblies in parallel. And I just need to, as the user, set up my sample names. So we'll just quickly name these first 2 S1, S2, S3, and S4. And so then that tells NGen, these 2 FASTQ files are part of the S4 assembly. These 2 are part of the S3, S2, and so on. And all of these samples are going to be assembled against that same reference sequence we loaded. This is going to run them as separate assemblies, but I'll show you how to compare these assemblies to one another when we get to the analysis steps. You can set up replicate sets if you have them here. It's especially useful if you're doing some RNA-seq assemblies. Next, you can set a control experiment. And then you're presented with some assembly options. We're going to be doing some variant analysis downstream. So I'm going to set haploid as my variant detection mode. Other than the variant detection, you don't have to set anything on this screen. All these parameters have already been optimized for the specific data type and workflow that we're using. So in most cases, these defaults are going to work really well and give a very high quality assembly. If for some reason you're having problems with the assembly results, you can give us a call. We have a great support team that can take a look at your data, see if there's something unique to your project that may require you to adjust these settings. And so then we need to name our project and set up a project folder. And a reminder, this folder, like all of our source data, our output folder is going to be up on the cloud data drive as well. So let's create a new folder on the root, cloud webinar. And we'll select that folder for our output. So each of these 4 assemblies will then be saved to that folder in a subfolder named Webinar Demo for our project. So then on the next screen, you can see the script that SeqMan Engine generated for this assembly. So this takes in all of our inputs so far and creates this script. You can save this script and run it again. This will actually automatically get saved to the DNASTAR Cloud data drive along with your results. And then I'm going to click Start Assembly. And this takes just a moment. What it's going to do is upload the script that we've generated and then kick off each of those 4 assemblies. So just as this is getting started up, if we have any questions so far, we could take a few right now.
Thanks, Katie. Well, now that we've seen Cloud Assemblies in action, there are a couple of questions from our participants. First of all, how many assemblies can be run at one time? Is there a limit?
So there is a limit, but that limit is actually just set by us internally here at DNASTAR. I believe the limit is about 90 right now. And that's just because each of these assemblies is going to run on a different virtual machine, so we don't want, an excessive number of virtual machines starting up, especially if someone had done that inadvertently. So that's going to meet most people's needs, I think. You're probably not going to want to do more assemblies than that at one time, just to make sure things are running as expected. If for some reason someone did have a need for more assemblies, we can increase that limit.
Okay, that's great to know. And also, how long does it take to transfer really large data sets to and from the cloud?
Yeah, so that's going to be dependent on your own internet speed. We've done some tests internally showing upload speeds of about 20 megabytes per second, which comes out to, I think, just over a gigabyte per minute. So it's pretty quick. And one thing to keep in mind is the upload and download step is just part of the process. As I mentioned earlier, and as you probably saw as I was looking at these files, everything is stored up on the data drive in a compressed format. So when you have a file on your computer, say a FASTQ file, and you select that to upload to the DNASTAR Cloud, as part of that process, the software is going to automatically compress that before it uploads it. So you don't have to do any of that compression yourself, but you get the benefit of a slightly smaller file to upload and download. And likewise, when you download the results, the software will decompress that for you as well.
Thanks, Katie. We have a couple more questions, but I'm going to hold those until after the next part of the demo. So you can go ahead and continue with your demo. Thank you.
Okay, great. Yeah, thank you. Yeah, please continue to ask questions. We have some analysis steps to look at, but we'll take the rest of your questions at the end. So you'll see here in this log, I get a status message that says the entire project was successfully submitted. So then I'll click Next, and here I can see my S1 through S4 jobs, and I can see the status of those as starting on the cloud. You can also see the status of some previous jobs I've completed, so those are done. If you want to go look at these, you can select the project and then either say download assembly or view the data. Again, you're probably noticing a pattern here. This is just going to open up our cloud data drive, and then you can download the compressed assembly results from there. So while our assemblies are running, I'll show you a couple other kind of data management things. One way to monitor your assemblies is to open this Cloud Assemblies or CMan Engine application again, just as we did in the beginning, and say monitor assemblies. But if you are out and about or traveling and you want to check on the status of your assemblies without having to boot up your computer to open Cloud Assemblies, we do have a web monitoring tool. So in the Navigator, if I hover over Cloud Assemblies, you'll notice a link to this tool. You can also get to this URL directly from our website. And so then you just need to log in again with your DNASTAR credentials. And from here now you can see the same information that we see in the NGen interface in our web browser. So we can see our assemblies are started. You can see which assemblies are finished. If you had any issues with the assembly, some status messages would appear here as well. You could also limit this just to the running assemblies. So if you want to filter out your assemblies that have already completed, recent assemblies, in the past 7 days, or you can show all of your assemblies. So that's just monitoring the assembly progress. Once your assemblies are completed, you can download them from CMan Engine, or you can open up the DNASTAR Cloud data drive from CMan Engine, or excuse me, the DNASTAR Navigator. And navigate to those files. So so here's some results I did earlier. Let's look for some that are named a little bit. Oh. So earlier I ran actually all 18 strains of the Salmonella genome that are part of this data set. And so you can see in my results folder, I have all of those assembly files. I also have some reports, the script like I mentioned, and just some additional reporting information. And so what you can do is select all of these assemblies and then click the download button. And now here is where we make that cloud to ground transition. So from this point, you can select a folder to download your results on your desktop computer. And then the software is going to begin the process of downloading all of those assemblies and decompressing them to a readable format. So you can see here we have the download starting, and you can monitor the progress here as well. So I've actually already downloaded all 18, so we'll just kind of skip ahead to that. So here I have my 18 assemblies that are downloaded from the DNASTAR Cloud data drive, and now we're ready for our analysis. So what I'll do is launch ArrayStar. This is our application for multiple sample comparisons, variant analysis, any kind of set creation that you're going to do with your next-gen assemblies. So I'll launch ArrayStar. start a new project. Here we're doing variant comparison. You see we also have CNV, RNA-seq, ChIP-seq, and miRNA options, so just depending on what kind of project you're doing. And then I'm going to drop my assemblies right onto this window. And this is going to load these up. You'll see we have 18 experiments loaded. Process SNPs. Here you can load information from our variant annotation database. If you're working with human data, this has some great annotations related to clinical data, evolutionary conservation, functional predictions, a lot of important tools for clinical researchers, but just anyone looking at human variants. I highly recommend importing data from the variant annotation database. Or you can upload your own custom SNP annotations. And then next, you just go ahead and start the loading. I see we're running low on time, so let me pull up the project where I've already loaded all of my samples in. So here you can see in the experiment list, we've got 18 experiments loaded. I can take a look at a SNP table to see all of the variants called in this project. As a table, you can easily filter this down. So you can filter, let's say you want to find SNPs in just one of your experiments. And you can even drill down a little more and say, show me non-synonymous SNPs. If you're using, if you have a bed file with targeted regions, you can look only for SNPs in those targeted regions. That doesn't apply here because we've done whole genomes. You can also filter on minimum depth, so look for SNPs that occur at a significant depth and frequency. And you can check against dbSNP as well as your custom SNP database. So recall when we set up our assembly, we added that custom VCF file. So now we can actually use that file to help filter our SNPs. So if we want to look for novel variants, we might choose absent, or if we're looking for a specific set of variants, you might choose present here. Or you can ignore that data. So let's do absent. And so this is going to show us variants in this one sample that are non-synonymous and essentially unique, at least unique to our SNP set. So that finds 104. You could repeat this for multiple samples and then save a SNP set. So I've done that ahead of time. So here I have some sets I've created for my different samples. Then you can compare those samples in your Venn diagram. So here I have non-synonymous SNPs in 3 samples. This intersection shows variants that are shared among all 3 samples. So maybe that's of interest to you. And then you can show the table of those selected SNPs. Or maybe you want to filter a little more directly. Let's say you have one sample that you're interested in and you want to find variants that are unique to that sample that aren't present in any of your other samples or in your VCF file. That's what this unique non-synonymous 70 sample or set I've created is. So I did that using our filtering dialog. You can see the filtering summary here at the side where I added in this criteria to also make sure it was absent from all my other samples. And so I can show a table of these variants as well. So that's a little more direct way of doing it if you don't want to use the Venn diagrams. And I've also added here a column for depth of coverage in that sample. So you can see at each position I have a variant call in this sample and none of my other samples. And then I can see the depth of coverage of that area. And as you hover over, you can get some summary information. You can also then send this selection to SeqMan Pro to visualize that coverage and that alignment. So when I send that, it should launch SeqMan Pro. Oh, okay. SeqMan Pro. Okay. So that launched SeqMan Pro, and here we can see the actual alignment at that position. You can also look at a strategy view with coverage here. I'm not going to show that today. It looks like we're running low on time, but we have some really nice new tools coming for this step actually in our fall release. So if you're interested in seeing more genome visualization tools, definitely stay tuned in the fall for some upcoming webinars on this part of the analysis. But just to sum up, you can see pretty easy assembly setup. And then once your assemblies are completed, you download your results to your desktop computer, and you can do all of your analysis right here in LaserGene Genomics Suite. And if you're interested in any particular analysis workflows, I definitely recommend you check out our other webinars. We have many webinars on different workflows, from RNA-seq to exomes to whole genome. We didn't have much time to cover the analysis today, but we have lots of resources available for that. So at this time, I can take any questions that have come in.
Thanks for the presentation, Katie. We have a couple of questions that are of a general nature about, about the cloud and how secure it is. The first one is, how secure is data that's stored on the cloud, and transferring data from a personal laptop computer or one at the company up to the cloud and back again?
Yeah, that's a good question, and something I kind of did gloss over here. So all of these cloud tools are hosted by Amazon Web Services, and so they have a pretty good reputation for data security. If you go to our home page, actually, and go to DNASTAR Cloud under the Software tab, you can see some descriptions of our cloud products, but also at the bottom, we have a nice document that actually details exactly how the data is managed and how the virtual machines that do the data processing work. So I won't go through this whole document now, but in summary, we use both authentication, as you saw during the demo, and also the data is encrypted at every step of the way. So the data is stored in an encrypted format, the results are encrypted, and the virtual machines that run the calculations are actually deleted after the calculation is complete. So you'll see we have this diagram here of the pathway and the workflow, and there's levels of security at each step of the way here. And so you can read this document to get more information on that.
Okay, that was really helpful, Katie. And another question is about how long data is stored on the cloud for. Is it up there for years or for a few days or what?
So our policy is we keep the data on your Cloud Data Drive account for 1 year after your license expires. So most people, they're going to do their assemblies and download the results. In general, we haven't seen a need for long-term data storage, but if there's someone who does have that need, please contact us, because this is just, this is an internal policy, and it's certainly something we can work with the user on. But it's important to note that it's, that data is stored in a secured fashion. We don't actually have access to your data here at DNASTAR, but we can, basically shut down that account after a year once the license is expired. And that's been sufficient for all of our customers so far.
That's great to know. So I guess that's the end of our questions and, of course, of the presentation. I'd like to thank our participants for joining us today, and we hope that you found this webinar helpful. If you do have additional questions, or if you have ideas for future webinars, you can email those to us at webinars@dnastar.com. And I'd like to thank you again for joining us. We hope to see you again next time. Thank you, Katie.
Thanks, Sharon. Thanks all. Hope to see you again.